Let's examine the pros and cons of solid-state relays and electromechanical relays and introduce the Si875x as an alternative. There are many applications that require switching AC or DC loads with an isolated input. Motor control, valve control, HVAC relay, HEV/EV car charging, battery monitoring, and AC mains line switching are just a few. These applications are typically served with electromechanical relays or solid-state relays. Customers of these relays are typically faced with limitations and compromises. Electromechanical relays use a coil, which when sufficiently powered can move an armature to switch contacts based on the magnetic flux generated. They have the benefit of truly being off without leakage current when not energized. However, they have many limitations such as their bulky size, which can limit product design, the difficulties with mass production mixing standard SMT techniques with these large devices, acoustical noise when switching, EMI noise due to arcing when switching occurs, wear out of the contacts due to arcing, slow switch times, and high expense. Solid-state relays address most of EMR's limitation by using silent semiconductor switching with no moving parts. They are fully integrated, offering small board space when used in low-power switching applications. Higher power switching applications must have larger packages to deal with the power dissipation and heat of the integrated FETs. However, SSRs have their own set of limitations. Quite often the SSR user must compromise on FET performance, power, or cost as there are limited choices of integrated FETs. SSRs typically use optocoupler designs to achieve isolation. These optocoupler designs are limited by LED technology. This typically limits operating temperature range below full automotive. As temperature increases, performance degrades as well. Designers can eliminate these limitations by choosing to implement custom SSRs with an isolated FET driver and an application-specific FET that is optimized for power, cost, and performance. The Si875x is ideal for switching between AC or DC loads. A single Si875x can support either DC or AC load switching, with one FET required for DC loading switching, shown in the upper left circuit, and two FETs required for AC load switching, shown in the lower left circuit. The Si875x is the world's first CMOS isolation-based custom SSR solution. Until now, only optocoupler-based solutions were available with limitations in high temperature operation, stability, and lifetime. The ability to use application-specific FETs lowers overall cost and enables optimized power and performance over the typically poor-performing FETs of integrated SSRs. The Si875x is easy to implement with no IC power supply needed on the switch side since power is transferred through the isolation barrier. Miller clamps are implemented that allow the optional addition of a capacitor to eliminate the possibility of inductive kickback changing the state of the switch. Low power operation is achieved with options for down to 2.25 volts input, a unique capability to offer lower static holding power while still achieving fast initial switching and an ability to provide 10.3 volts at the gate with only 1 mA on input current. Typical SSRs require 10 mA input current. The switch side circuits shown are identical whether you're using the Si8751 or Si8752. The Si8752 diode emulation can be convenient for customers moving from an existing optocoupler-based SSR, as it works the same way while the Si8751 digital input is used in typical controller-based designs. The Si875x is in production now with a narrow-body 8-lead SOIC. The Si8751 provides a pin to control how much current is consumed by the supply when the input pin is logic high. The more current consumed by the input supply, the faster the output can turn on the external FET. This allows the application designer to optimize the trade-off between power consumption and switching time. Typically, this pin is connected to the supply ground through a resistor. The greater the value of the resistor, the less current is consumed by the input supply. Values can range from 0 ohms, shorted to ground, to open, DC not connected. In addition to a resistor, a capacitor, typically 0.1 microfarads, can be placed in parallel to the resistor. This allows the device to draw more current to switch the external FET on quickly, yet draw less supply current in the steady state. Total power over time is reduced while maintaining fast switching of the FET. The Si875x evaluation board simplifies evaluation and makes it easy to replace replays. The boards come populated with either the digital input of the Si8751 or the diode emulator input Si8752. The board includes screw terminals for quick evaluation of the device's key parameters and also includes test points on each of the device's pins to accommodate direct connection to the designer's end system. The EVB supports both DC or AC switching and has jumper selectable options to evaluate TT power reduction and Miller clamp functions. The Si875x is the world's first CMOS isolation solution for creating solid-state relays. The benefit is longer life, lower power, and more stable performance. This product enables the use of application-specific FETs that potentially lower cost and maximize performance. SSRs are completely silent and have a much smaller footprint than EMRs. Full automated 125C operation is supported. To find the datasheet, EVB user's guide, and more, visit scilabs.com/Si875x.